Energy changes affect different elements and compounds differently. When heat is added to a system, the enthalpy of a substance increases. Assuming the pressure and the temperature of the system stay the same, the temperature of that system may change. The temperature change will depend on two factors: the mass of the elements or compounds inside the system will affect the temperature change, and the specific heat capacity of the element or compound in the system. Specific heat capacity is defined as the amount of energy needed to raise 1 gram of a particular substance 1 degree Celsius. Here you could see a specific heat capacity table of some common substances. The substance listed here that has the lowest specific heat capacity is sand. It takes only a little heat energy to increase a 1 gram sample of sand 1 degree Celsius. By comparison, it would take a whole lot more heat to raise 1 gram of water 1 degree Celsius, 4.184 joules of heat, because water has a high specific heat capacity. The specific heat capacity of a substance depends on many factors, including the type of molecules in the substance, the arrangement of the atoms within the molecules, and the interactions between the molecules. In these examples, we have water and sand, the same amount by mass of each of them, and we're starting with the same temperature. We're applying the same amount of heat, but you could see the temperature of the sand has increased dramatically given the same amount of heat energy compared to the water, because water has a very high heat capacity. It can hang on to that heat energy for a lot longer and see only a small increase in temperature, but sand can't handle that heat well, and you see a dramatic increase in the temperature of the sand. Let's assume that I'm taking these samples of aluminum and iron, which have the same mass, and I bring it outside into the sunlight. Which will feel hotter in about a minute? Well, you could take the specific heat capacity of aluminum, compare it to the heat capacity of iron, and if we have the same amount and we're applying the same heat from the sun, then iron would heat up faster. It has a lower specific heat capacity. If I were to include copper, copper has a heat capacity that's even lower. Copper's heat capacity is 0.384 joules per gram degree Celsius. Think about a slide in a playground. Which metal would you want your slide to be made out of? Aluminum, iron, or copper if you had the choice?